Hey everybody. This is a problem that I posted for my guys for some math contest prep. If you want to give it a read, give it a shot, see what you can come up with on your own. Then I'm going to go through the way I solve the problem. Maybe it's of help. Okay, pause it now, give it a shot on your own. Otherwise, here we go. We're going to walk through a solution for it. So the problem basically says, where does G lie on AF so that those two rooms, and I'll just call them like the red room and the purple room, have the same area? So the first thing I notice is I don't really have all the dimensions going around that shape. I do notice that CD is equal to DE, so maybe I just call those like X if I wanted to find what all the dimensions of that room were. And so I could kind of first tackle that part. By doing that, I know that my total area is 11.2 meters squared. So if I just tried to calculate the area of that shape, then what I might do is I might go through and I might break apart that composite figure into two boxes. And you'll notice that what I did is I just kind of chopped off the top going across horizontally. So what that's going to do is give me like maybe a box 1 up top and a box 2 down below. So if I went through to calculate the area of that, well then I know I've got some dimensions. At the very cross, at the top, I know that that has to be 4 minus x all the way across the bottom less x. And that'll give me the ability to calculate the area of my total. That has to be the area of box 1 plus the area of box 2. So my area of box 1 would have to be 1 dimension times the other dimension, since it's a rectangle. And now my area of the bottom rectangle, box 2, would have to be 1 dimension times the other dimension. I know that that total area has to be 11.2 meters squared. Okay, that creates a linear equation for me of which I can go through and I can expand my brackets. I can collect like terms with my variables. That means I want to isolate my x. And when I divide out my 2, I'm going to get 1.6. Now, maybe I just leave that as a decimal for now, but there is my value for x. So what I'm going to do is I'm going to go ahead and I'm going to label that dimension, that x, just over and in orange. So my x is really 1.6. Okay, I think that changes the question now. Because now I know the dimensions of the parts of that shape. So like up top, where that length was 4 minus x, it's now 4 minus 1.6. That makes that dimension 2.4. And so now I have a better sense of what that original room is. Okay, I think my problem solving now changes. So what I'm going to focus in on then is, how do I get point G to lie in a position that makes the red room equal the purple room? So to do that, I'm going to put my solution in orange. I'll match my dimensions up top. I'm just going to shrink down that diagram to give me a little bit more room to write. To do that, I think I can make that conclusion pretty quickly, that if the total area of the room is 11.2, and I'm going to break it into 2 equal rooms, then each room must have an area that's half of my 11.2, or 5.6 meters squared. So what I can do then is I can make the assumption that room 1 is 5.6, or room 2. I shouldn't even say 1. The red room is 5.6, or the purple room is 5.6. So if I take a look, I do notice that my red room is the rectangle of box 1 plus the area of that triangle. Or the other way, my purple room is my box 2 then subtract the area of that orange triangle. So really my focus becomes, okay, can I manipulate either one of those areas to come up with the area of each individual room? To do that, I really need to know the area of that orange triangle. So what I might just do is I'm going to work through on my red room. I know my red room has an area that is box 1 plus the triangle. Well, now that I know that that top dimension was 2.4, if I want to say the area, I don't know, I'm going to put an R underneath there, or a red to be explicit, is going to be the area of box 1 plus the area of the triangle. So I know then that 5.6 is the actual area of the room. My area of box 1 is now 2.4 times 2. I don't know the area of the triangle because I don't know the position of G. But if I used a different variable, and maybe I said, I'm going to call that dimension Y, then I can calculate the area of that triangle by saying I know the area of a right triangle is half the base times the height. And what I just created then was an orange equation of where I can solve for the value of Y. So pretty quickly, I can make those calculations. When I take my half of 2.4, that's 1.2. I can isolate my Y term. So 1.2Y is going to equal 0.8. And now, when I go through to divide that, I could write 0.8 over 1.2, but I'm hoping that we recognize either that that's 8/12 or that we have a common factor of 0.4, and so we can reduce that whole thing down to 2/3. Okay, that tells me, and just to avoid all of the same color on the diagram, I'm going to just sneak in green that Y is now 2/3 of a unit, in this case meters. Okay, the question asked me, where should G be located on AF? So that means I need to give the position of G relative something. So what I could then do, and I'm going to do this in green for my final answer, I could say that that position of G is going to have to be 2 plus 2/3 units from A, of which if I went through and I simplified that, I get my common denominator. That's going to tell me that I'm 8/3 units from A. Or I could, of course, given my position based on F. Well, if that's 2/3, then really what I have is 1.6 minus my 2/3 from F. And if I look at 1.6, 1.6 is 8/5. So that's going to end up giving me as a common denominator my 15th. So that's 24 minus 10 of them. And if I sneak all that up, as I feel like I'm getting really messy here, then I could say that it's 14/15. And I really do need to put this meters in there from F. So my two solutions, as long as I'm 8/3 meters from A or 14/15 meters from F, then I have the position that makes both of those areas equal. I like that problem. That was a great problem. Good find. Okay, I hope that that problem helps you. I hope you found it interesting, and I hope the solution helps you in your prep. Okay, keep it up. Well done.